Okay, so last time I remember we were discussing about the discrete mathematics, right?
Yes, sir.
Yeah. So can we continue where we left, or what do you prefer?
Yes, uncle. Yes.
Okay. So did you find time to go through the one what we covered that time? You are okay with that? Any questions or
Yes,
any?
yes, uncle. I'm okay with that. The PPT you sent, I'm okay with that.
Okay, PPT also you have gone through. Okay, because what happens the most of the time, the terminology is the one we need to be careful with, because there will be too many wordings coming one after the other, and we need to be knowing that what is happening with that. Okay, is that okay?
Yes, uncle.
Okay, let me open the document. This is summertime, so not too many students are studying, and even I canceled one session with you. And last time you are fine with that? Your health
Yes,
was having
yes, uncle. Yes.
okay. Okay, functions. We started with the functions, if I am not wrong, isn't it?
Yes.
Function add and partial functions, total functions, one-to-one function, injection. That is where we were, right?
Yes, sir.
Okay. Okay. Let me share that. View full screen. Now I will share the share. Okay, can you see that?
Yes, sir.
Okay, good. Okay, here, okay, so your function f, a to b, that is, a is the input, b is the output. That is
Okay.
okay. The function is doing that job. Makes sense to you? Okay, so don't take it only in the literal mathematical meaning. It could be something like uh, a process. Actually, function is the word, the right word, but we use the function for many things. Like in mathematics, there is a function, and the Indians mostly used all festive season celebrations as function. Do you see that?
Yes, uncle.
So the process, something is in operation, like even the mind thought process. Let's say I question you, what is your name? What will be your answer?
My name is Karishma.
Yeah, so you see, there is an input given to your mind, and your brain has done a process, and you have given an output. Do you get that?
Yes, uncle.
So name is the question, is the input to your brain, and the brain is functioning on that question, and the output, the answer will be Karishma. So that is what F is, the brain process of finding the answer for the question, that is the input A, and the output B is the Karishma. Makes sense to you?
Yes, sir.
Okay, so it's not that like f of x, x value given as a 2, and according to the definition of the f of x, the 2 will be substituted wherever the x is appearing, and we will get an answer. Mathematically, that is a function also. So that nothing wrong with that. That is also is fine. That is in the pure mathematics. But in discrete mathematics, we need to cover everything, not only the definition of a pure mathematical function definition. Is it okay?
Yes, uncle.
Okay, so the A to function f, which make the A to become a B, is an injective or one-to-one function if and only if whenever x comma y element of A. So we are taking both the x and y are element of A, and f of x equal to f of y. If you take it as a condition, that means for two different input, the output is the same. Do you understand that?
Yes, uncle.
That means then x is equal to y. Then the input must also be equal. Then only it is a 1-to-1. Makes sense to you?
Yes, sir.
Okay. Alternatively, f is injective whenever x is not equal to y implies f of x is not equal to f of y. So they will be distinctly different output for every different input. Okay. And they cannot be like one input cannot have more than one output, and also more than one output cannot be mapped to one input. Makes sense to you?
Yes, sir. Yes, sir.
Okay. So that's what the injection property is. Some outputs implies the same outputs implies same inputs. Equivalently, different inputs implies different outputs. That is what I was saying earlier. Okay.
Yes.
Okay, now we are taking an example, a pure mathematical thing. As an example, function f, that is a real going to a real output. Given by, first example is a linear function. F of x is 1 minus 2x is injective. But g is another function which gives a real input to mapped to a real output. Given by g of x is equal to x square is not injective. We know that, but why it is so? This is because f of x equal to f of y. So first example is the linear thing. So we take that one. That is f of x definition is 1 minus 2x. Now, as f of x is equal to f of y, then according to the definition, linear function definition, 1 minus 2x is equal to 1 minus 2y. That implies minus, we can cancel the 1 on both sides. Minus 2x equal to minus 2y implies x equal to y. So we have proved that when we equate the two different outputs are equal, and through the definition of the function, if we can prove that both the inputs are equal, that means it is 1-to-1 function or it is a injective. Makes sense to you?
Yes, sir.
Okay. But in the case of, if you start with a definition, take two different inputs, that is minus 2 and plus 2, which are both are real numbers, but they are not equal. So the two different inputs are not equal. But if you give those two different inputs to the function g converts either 2 or minus 2 to a 4. So that means it is not 1-to-1. Do you get that?
Yes, sir.
Okay, so can you tell me the wording for this one? When two different inputs, minus 2 and plus 2, both become a 4. So it is not 1-to-1, but can you give another wording for that? Many to?
Oh, yeah, many to 1.
Many to 1. Okay. Okay, so that is what it is. So we need to always use our understanding and the logic and everything to, first of all, understand this thing, and also how to go about expanding our thought process and further idea about that. Is that okay?
Yes,
So
sir.
don't reserve or keep it like only I will follow what has been told to me, and I won't think beyond that. I won't work beyond that. That should not be the case. Okay. Okay, 1-to-1 function given an alphabet alf like real, natural number, complex number kind of definition. Alphabet is written as a alf. Okay, so the function name is reverse. So alf, whatever the alf input is going to map to output as a alf. So an example 1-to-1, but the length is going to, so the reverse is going to be whatever the word we are giving, it will be reversed. Okay, but the length, if you give the word in alphabets and the number of letters in that is not 1-to-1. Okay, so there can be a word length, two different words, two different input, but the length, the number of alphabets may be the same. Do you get that?
Yes, sir.
Okay, so for example, true, how many letters are there? Is 4. Word, W-O-R-D, that is also 4. So if you count the number of alphabets in a word, then that is not a 1-to-1 function. But if you take a different function, which is reversing the given word, the true will be reversed as a E-U-R-T. Do you get that? And the word
Yes.
will be reversed as DROW. Okay.
Or-
OW. Okay. So next, so you are clear with the injection, right? Property, that is 1-to-1. Okay, now we go to surjection. So the range of F. So remember the range, codomain, and what is the third one? Domain, codomain, range.
And-
There are three of them. Do you get that?
Yes, uncle.
So the domain is from the input side. Okay.
Okay.
Okay, the codomain and the range both are on the output side. So that is how I remember and understand. Okay. Because if I ask you straight away, okay, before I try to explain them and give a way for you to remember them for the definition, can you explain me what is a domain, what is a codomain, and what is a range?
Okay, so 1 second.
Don't go for any textbook or anything. I'm saying
No, uncle, no,
yeah,
uncle.
you're thinking, right? Yeah, okay.
To explain it, I'm thinking.
And I
Like,
give the clue. I give the clue. The domain is from the input side. Both the codomain and the range are from the output side.
yes, uncle. So, okay, suppose we have a set A, the number of the elements in A is the domain.
Okay, so within what value to what value
What
the
value
inputs
to
are
it is,
going to
it
be?
is the
Yeah.
range.
So that is the domain. So that means, for example, if the input is going to be real numbers, real number is our domain. Do you get that?
Yes, yes, uncle.
Real quantity. So if it is going to be a natural number, then that is our domain. Okay, fine. So you are taking a function which can take a domain as the input from a real number. Fine. Then what is the meaning for the definition for the codomain, first of all?
The elements that it's mapped to.
Okay, so now you are already started, the function has to map to something. So don't restrict your thought process like that, because it is not the function which is doing all the job. It is the requirement what we are looking for. Do you get that?
Okay.
Okay, so the function itself may have its own, if you give something, it will going to give output. That's okay. But we may, like, as the function has its own job to do, we may have a need or a requirement how the input should be and what the output should be. Do you get that?
Yes, uncle.
And when we bring in a function, then we are checking whether they fall in place. Do you get that?
Yes, uncle.
So don't always think like it has to be mapped. That is why we have another one called a range coming into picture. Makes sense to you?
Yes, uncle.
Okay. So let's say all the input, the characteristic of the input is covered by the word called domain. The output side is covered by codomain. Do you get that?
Yes, uncle.
Okay. But this is have their own freedom. So still we are not making any mapping or bringing a function. But let's say if you bring in a function, then if you fit into the domain and codomain, if the function can convert all the input from the domain to the codomain, then the codomain will become the range of the function.
Yes.
Is that okay?
Yes, uncle.
So that means there could be a domain and codomain, and when you bring in a function, there may be some input, may not have output through that function. Do you get that?
Yes, uncle.
Or there may be some codomain elements may be available, but may not be mapped back to the input side of the domain.
Yes.
For that function. So for example, take the square function. Okay, square function. So like, okay, I mean, square root function. Okay, square root is a good one. Okay, let's say our domain and the domain is, let's say, is a real quantity. Is that okay?
Yes, uncle.
So negative numbers are also real numbers. If you take a negative number and give it to the input of the square function, the output will be a complex number. Do you get that?
Yes, sir.
Okay, but now the complex number by itself is not in the real. So let's say we define that the domain is real or the codomain is also real, then that particular thing is not falling in place. So there may be, okay, so the codomain, I would say that it can cover anything. So the negative square root of a negative number should be covered by the codomain. Do you get that?
Yes, sir.
So in that case, we don't find the, so when you bring in the definition, so as such, maybe maybe the way I explained you confused you also, because I get lost a bit. Okay, let's think about we want real to real. Do you get that?
Yes, sir.
Okay, but when the function comes as a square root, then there is a job that can be done by the function. If you give the negative number input, the function will give you an output, but that is not falling in place of our definition of the output. Do you get that?
Yes, sir.
That is where makes the difference between the range and the codomain. Okay.
Yes, sir.
Okay, let's take it. So further, then we can understand how that has to be looked into. If the range equals the codomain, we call the function surjective. So that means, so like the linear function. So you take the domain as the real to real mapped. Then if the function is a linear function, then any real quantity input to a linear function, you will get an output that will be fall in the linear real also. Makes sense to you?
Yes, sir.
Then that means the range equals the codomain. So we don't have any output which is not falling in the inside the range. Is that okay?
Yes, sir.
The range equals the codomain. We call the function as surjective. So that is also called onto. It maps the domain onto the codomain. Okay.
Yes, sir.
Okay. So thus function f a to b is surjective if and only if every element of b in the image under f of some element in a. So, but this will work for a linear function. But if you take a like a square root kind of thing, it won't work. Makes sense to you?
Yes, sir.
Okay. So the injective is 1-to-1. Surjective is called onto. Okay.
Yes, sir.
Okay. As an example, the real, okay, 1 minus 2x is surjective, but the g of x square is not surjective. Okay.
Yes, sir.
Okay. This is because if a is an element of R, then a equal to f of x. Okay, so that is we are saying a is equal to, so it's a real value. Do you get that?
Yes, sir.
How to find the x value? Then just write the a equal to 1 minus 2x and rearrange the subject as a x. Then x value is given by minus 1/2 of 1 minus a. Do you see that?
Yes, sir.
Okay, so that means minus 1/2 of 1 minus a, as a is a element of R, then you plug in a real value for the a, 1 minus a real number, whole thing multiplied by minus of will be a real number. X will also be a real quantity. Makes sense to you?
Yes, sir.
Okay, but g of x is not equal to minus 1 for every x element of R. So meaning, let's say, because we are saying for the g function also, the real quantity maps to a real quantity. That is what the g function is supposed to do. Do you get that?
Yes, sir.
But from the output side, let's say we take the output real quantity as a minus 1. So that is what mathematically written as g of x is. If it is a minus 1, then if you look for x, the answer will be a square root of minus 1. Do you get that?
Yes, sir.
So that means, yeah, that is not available. So that is why we write it as for a x value, for negative output values, you don't find a input.
Okay.
Because
Yes, sir.
G has output also. All the real quantities are available for the G. Do you get that?
Yes, sir.
So from the output side, we are talking from the G function, both positive numbers, negative numbers, zero, everything should be available. But there is no input available for the G which can give an output as a negative number. Makes sense to you?
Yes, sir.
Okay, so you see the output is a bigger. So now the output, even though it has all the real quantities, that we are going to call that as a codomain. So the domain and the codomain is now defined. Both the domain and the codomain are real values, but the G function is a square function. So looking from the output point of view, let's say I want to get an output as a -1, then we don't have an input that can be given to the G function to find the output as a -1. Makes sense to you?
Yes, sir.
Or you want me to write it down, or you're okay with that?
Yes, uncle, I'm fine.
You're okay with that?
Yes, yes.
Okay. Okay, now the bijection. A total function. Now, do you remember the total function definition and the partial function definition?
Definition. One second.
So the total function is the one what we learned in pure mathematics, okay?
Okay.
Function will cover all the definition of they mean everything for the input. For it is defined everywhere. That is what the total function is.
Okay. Yes, uncle.
So if your function is defined, then if you give an input, the output will be available. Do you get that?
Yes, uncle.
But a partial function is mostly the pure mathematical functions cannot be a partial function. Partial function will be like it will be like the process. Like I said, the example of what is your name, something like that. Do you get that?
Okay. Yes, uncle.
Okay. So now if I ask you, okay, well, if I ask the question like, what is your husband's name? You don't have an answer. You cannot process that. Do you get that?
Yes, uncle.
So that even though the job of the brain is to work out the question and give, if you ask for a name, your brain supposed to process it and give an output. Do you get that?
Yes, uncle.
Okay, so let me go quickly. What is the partial and the total functions too? Okay, so this is the example that they have given. Okay, so in mathematics we generally only consider total functions where f of x is well defined for all elements of x of the domain D. Makes sense to you?
Yes, uncle.
Okay, but in computer science or the discrete mathematics, partial functions are also important. That is when f of x may not be defined for every element of the x of the domain D. So that's the example I given you. Here they may have given a different example. A function mother. So the mother is the function. So the process is that is what the job has to be done. If you give input, it will map the men domain input to the codomain woman is total because every man has a mother. Do you get that?
Yes, uncle.
Okay. So, but a function, eldest sister. So, like for you also, like if I ask you what is the name of your eldest sister, your answer will be you don't have it. Do you get that?
Yeah. Yeah.
It's not that everybody should have a sister or a brother. Do you get that?
Yeah. Yes, uncle.
That is the meaning. Makes sense to you. So something may not be there. That is what. So this is more a kind. This is why we call this as a discrete mathematics. Okay.
Okay. Yes.
A function eldest sister. So the input is a man and output is a woman. Looks similar to the previous function mother, but this is partial because not all men have sisters. Makes sense to you?
Yes, uncle.
Okay. So yeah. So, but in the mathematics, real to real, the function is square. Then x becoming a x square is total. Do you get that?
Yes, uncle.
Okay. The function reciprocal in mathematics also there is one thing here. Okay, there is a good example here. I was wrong. I was saying that the pure mathematical function is always total function, but this is a good example. So the function is reciprocal. You know what is reciprocal, right?
Yes. Yes, uncle.
Okay,
One by.
Yeah, real value mapped to real value with x input because of the function definition, it will get the output as a reciprocal of the x, that is 1 over x is partial, because 0 is a, let's say take 0 as the input. 1 over 0 is not defined. Do you get that?
Yes, sir.
Okay, so that is what. So because infinity is not part of a real value. Okay. Any question?
No. No.
Yes, okay. Okay, then the function. Okay, these things we have already seen. Okay, here let's quickly go through this also. A function f, domain going to codomain is total if and only if for each x element of domain there is an element of y of c with y equal to f of x. Do you understand this?
Yes, sir.
This is a
Yeah.
straightforward definition, like domain
Yeah.
mapped to codomain, but now we are looking for all the element in the input should be mapped to the codomain. That is also been, if this happens, then automatically that it may lead to this injective property also. Is that okay?
Yes, sir.
Okay, so whether a function is regarded as partial or total depends on what the domain is taken to be. The domain of definition of a partial f, D mapped to C, that is domain to codomain, is the set domain prime. So now we are saying that we reduce so that there may be inputs that can be given to a function, but output may not be available. Do you get that? So the eldest sister is the function and min is the input. Do you get that?
Yes, sir.
So for the function eldest sister, min available, all the mins in the world are available, but the output is not available because of the function.
Yes, sir.
Okay, so the domain is a very bigger picture. Domain may cover lot of things, but according to the definition of the function, the output we are looking for may not be available in the codomain. Make sense to you?
Yes, sir.
Then what we do, we separate so that means the function is not defined for all the elements in the domain. Is that okay?
Yes, sir.
Like even for me, I mean, I don't have an elder sister, so I have only one. I have one sibling, and it is my younger sister. So even I belong to that community. You belong to that community. Okay, let's stay with the min itself. The input domain is the min. The overall min in the world is the big domain. But if you take the function as the elder sister, only certain men will have the elder sister. Do you get that?
Yes, sir.
So if you separate out only those men who are having the elder sister, that is what is written as a D prime here. Understand that?
Yes, sir.
So the domain is a bigger domain and output is a codomain. So when you define the function, there may be some input elements may not have an output because of the definition of the function. But so those kind of function is called the partial function because it is not defined for all the elements of the domain. But when we try to extract out partially the elements in the input and make it as a domain, so that is the partial domain. Do you get that? So D
Yes,
prime is defined as X is an element of D. So X belongs to the D, but that X should have an output. So there is Y element of codomain with Y mapped to f of X. Makes sense to you?
Yes, sir.
Okay, so that is where so we could regard f as a total function from D prime to C. So that means to begin with, there may be function, a total function D will be mapping to the C. All the domain will have some element in the codomain. That is a total function. But let's say there is a function. When we look into it, there may not be some output available from a function for inputs from the domain. So we extract the only those elements in the domain which can be mapped to the element in the codomain, which is, we write it as a D prime, then definitely D prime to C will be a total function. Do you get that?
Yes, uncle.
So we separate, let's say a function is a partial function, then we can separate the domain such a way that we can make that partial function to become a total function if we change the input domain side as a D prime mapped to C. That is what it is. Okay.
Yes,
No?
uncle.
Right. Then we looked into this, and the surjection, and then, okay. Yeah. There we saw the total.
I think it's after.
This is not this. Range is a subset of the codomain. Okay. This one we have seen. And then, yeah, in the bijection, we started the bijection. Okay, the total
Yes.
function, that is what it started. That is why we went back. Is that okay?
Yes, sir.
Okay, so you are clear with total function, partial function, injective, which is 1-to-1, and surjective is onto.
Yes.
All definition are okay.
Yes, sir.
Domain, codomain, and range.
Yes, sir.
Okay, so now we go for the next property name terminology, bijection. A total function which is both injective and surjective is called a bijection. So we now include two different properties, and if a total function will have both these properties available. Okay.
Yes, sir.
Bijection is actually the intersection of injections and surjections. So function double or mapped to or defined by the rule double of x is actually twice the x. Is a bijection. That is, every real number can be doubled and every real number is twice some other real number. Makes sense to you?
Yes, sir.
Okay. There exists a bijection between finite sets A and B if and only if the mod A is equal to mod B. There exists a bijection between finite sets A and B if and only if mod A equal to mod B. What is the meaning of mod A equals mod B? Because the mod set mod definition, I need to look into 1 second. Function sets. Okay, let me look into the sets quickly and then see how this goes. Okay, because in the sets also you study the set separately, right?
Yes, sir.
So in there are a lot of notation. Let me quickly see the. Are you seeing the one which I opened newly?
No, uncle, you had stopped sharing.
Oh, the sharing has stopped. Okay.
Yeah, yes.
Okay, let me quickly check what is the mod symbol means for the set. So element of set, subset, and null set, all these definition are there. Proper subset, defining sets, everything is okay.
Uncle, I can't see your screen.
Yeah, I could see that because I went to the previous note.
Okay.
It's a set. I'm checking what this particular notes is saying. What is the meaning if you put the mod on a set? Because set we know, right? But we know if it is a number quantity or some quantity mod, then we know that is only the magnitude. Do you get that?
Yes. Yes.
But if you put the mod on a set, then I'm not sure what is the meaning of that. Do you get what I'm saying?
Yes, uncle.
Okay, I'm just going back in the notes, the previous notes, where they have written what is the meaning of the mod. because for difference they use the backslash. Okay. Whether they have, okay, they have a Cartesian product is one another definition. Okay, ordered pairs have a different bracket. Okay. What is a mod of a okay. Cardinality of number of elements it contains. When we use mod to denote the okay, cardinality is the terminology. Okay.
Okay.
Okay, so if you put the mod on a set, it will tell you how many elements are there. Do you understand
Okay.
that?
Yes.
Okay, let's say a set is the all the possible outcomes of throwing a die.
Okay.
Okay, then what is the mod of that set? Sample space.
Of throwing one die.
Yeah, one die.
Okay. 6, right?
Yeah, 6. They see that. Okay, so the sample space set will be written as within the flower bracket 1, 2, up to 6.
Yes, sir.
If you take this flower bracket 1, 2, 3, 4, 5, 6, and if you put a overall mod, then we are asking for the cardinality of a finite set. That answer will be a 6. Makes sense to you?
Okay, fine.
Okay,
Yes,
so
sir.
there is a definition coming from there. Okay, let me even share that and show that to you. Where is that? Where is our meeting? Okay, share. Can you see that?
Yes, sir.
Okay, so this is the previous notes. Okay, the notes title is sets. So it's the terminology is cardinality. Cardinality, card. It is like the token. Do you see that?
Yes, ma'am.
Okay, so how many of them? So cardinality of a finite set is the number of element it contains. We use the mod of x to denote the cardinality of x. Example, mod of 1, 3, 5, 6, 8, 12, 15, 18. If you count how many of them, there are 8 of them. Is that okay?
Yes, uncle.
Okay. And the mod of x is 0 if and only if x is a null set. So if there is no element in that, then the mod of x will be 0. A set of cardinality 1 is called a singleton set. So if there is only one element available, then it is called a singleton set. If x and y are disjoint finite sets, then the modulus of x union y will be modulus x plus the cardinality x plus, I should not use the modulus. Modulus is wrong word. Okay, the cardinality of x union y is the cardinality of x plus cardinality of y. Now tell me what is the meaning of this disjoint finite sets. So here they are starting with the definition. If x and y are disjoint finite sets, then this is written.
Yes, uncle.
Do your thought process and try to give an understanding for yourself what could be the meaning of disjoint sets.
When they do not have an intersection.
Good. That's the thing. So the two sets are completely disjoint. Disjoint, that is the English literal meaning. Do you see that?
Yes, sir.
There is no connection between two. Because probably the generic one is the cardinality of x union y should be cardinality x plus cardinality y minus cardinality of x intersection y. Makes sense to you? You know that general property, right?
Yes, yes, yes.
Yeah, A union B is actually equal to A plus B minus A intersection B, right?
Yes, sir.
Okay, so that is what it is. Okay, okay, here it is written. In general, if it is not a disjoint set, then this is what it is. Okay.
Okay.
Okay,
Yes.
anyhow, we go to the other one where we are. So there exists a can you see the bijection page? Now. what you are seeing now? No, on the screen, shared screen, what you see? You see bijection, or you still see the cardinal?
Bijection.
Bijection. Is that okay? So we went from here only. Okay.
Oh, yes, sir.
There exists a bijection between finite sets A and B if and only if the number of elements in A should be equal to number of elements in B. This is more understandable, right? Because every element will be mapped to some element in the output, and if it is a onto and one-to-one, then if there are n number of input elements available in the domain, then there should be equal number, n number in the codomain also. Make sense to you?
Yes, uncle.
Is that okay? Because bijection is a property if a function has both the injection and the surjection property. Okay.
Yes, uncle.
So injection means every input from the domain should be mapped to a one distinct output in the codomain. Is that okay?
Yes, uncle.
And surjection means the output should be mapped back to some input. Not clear to you again, the surjection.
Yes, uncle.
So the surjection, you are okay with the injection? Like
Yes, uncle. Yes, uncle.
one-to-one is okay, but surjection is a bit of a tricky definition, but let's try to do that again. So there are two ways to check whether a particular function is falling under the surjection property or not. One is the example of the real value. The real value is we try to take a output, which is A, which is element of a real quantity. And that means we can say that A is equated to f of x. Then write the A equal to, the definition of the f of x is 1 minus 2x. Rearrange the subject as a x. Then we get x is given by minus of multiplied by 1 minus a. You're okay with that? We do a bit of a mathematics starting from taking a output A, which is element of the codomain real quantity.
Yes, sir.
Okay. And finally, we find a input. So the input is going to be x is going to be equal to minus of multiplied by 1 minus a. So that means any distinct output will have a unique input x value, which is given by minus half of 1 minus a. Makes sense to you?
Uncle, could you repeat that last sentence? Your voice is
So now, no, I'm saying that I'm reading this line. This is because if A is an element of R, so we start from the output point of view. A is a element in the codomain, which is a real quantity. That means A can be written as a f of x. Do you see that?
Yes, uncle.
Yeah, output element is equal to the function f of x. Then write the f of x definition 1 minus 2x. That is A equals 1 minus 2x. We know that output A is given by 1 minus twice the input value x. Now what will be the input? The x is written as minus half of 1 minus a. Is that okay?
Yes, uncle.
Okay, so now we are saying that for any output, real output A, if you take the minus of that output and add 1 to that, that is 1 minus a, that will be a real quantity, and multiply that to minus of, that will be the input. Do you understand that?
Yes, uncle.
That will be unique. If a value is different, then the x value accordingly it will be a different. So f of x is a 1 minus 2x is a straight line. Do you understand that first of all?
Yes, uncle.
So if you take any x value, the output value will be only one particular value. It cannot be a output of any other input. Do you get that?
Yes, uncle.
Okay, so mathematically it will be very easy for you to understand. Let me use the whiteboard. 1 second. This understanding discrete mathematics is not going to be that.
Okay.
That
Yes, I understood.
yeah. But I totally agree where we get confused because
Yeah. The
way of-
terms are
the terms and also because we have to understand without going for example like that. Do you get that?
yes,
That is
uncle.
where the whole problem comes. 1 second. Whiteboards. Let me take the whiteboard. Okay, a new whiteboard. But there is a good thing about the discrete mathematics. What that is if we can make our brain process and the thought process along those lines, our ability and the capacity of doing things will increase a lot. Do you get that?
Yes, sir.
Because we have been trained by somebody and also we trained ourselves. The brain should think and work on a particular way. That I would call that as a pure mathematical way. Do you get that?
Yes, uncle.
That is we are looking for a definite answer, and a definite answer for that we are going for a definite proof or understanding in a mathematical way. That is how our brain works.
Okay. Yes, uncle.
But we can increase that capacity. We don't need to think in that way. Can we think in a much more bigger picture? Because the discrete mathematics is a bigger picture than a pure mathematics with respect to the property. Do you get that?
Yes, uncle.
Okay. Okay, I will put it in a more practical example. Like the jobs we do and how we interact with people, everything can be defined as a function. Do you see that?
Yes, uncle.
But when live entity brought into picture, then we cannot put them in a very straightforward definition like a mathematical function. Do you understand that?
Yes, uncle.
Let's say we both are interacting, and one session you may be answering everything correctly, and your whole understanding, thought process, concentration, everything may be on the thing what we are talking about. Do you get that?
Yes, uncle.
So I will be like seeing Karishma as a normal Karishma, like because you are giving all the answers. Always you used to do that. So your concentration and everything is helping. But there may be one particular session where you may not be having the full concentration because of some reason. So maybe the same question or the concept which you understood and you are capable of answering, you may not answer that time. Do you get that?
Yes, uncle.
So that is where the discrete mathematics comes into picture. So a pure mathematics will get confused because you're supposed to know that, because Karishma has been defined like that according to pure mathematics.
Okay. Yes, uncle.
But the other things like the reality and the character of the person and the live entity and everything put together, that has to be taken into consideration. So discrete mathematics will take into consideration. Do you get that?
Yes, uncle.
Okay. So that can be put up like why we have to learn such a thing and everything, because what are all we are studying, one way or the other we have to finally use it for the reality. Do you get that?
Yes, uncle.
So the reality involvement will include the human beings, other lives and species and everything. So that is why studying that part of the not defined, not very well, like it could be ambiguity, like sometime it may work, sometime it may not be work, that also taken into consideration.
Okay, yes, sir.
So you are interested in going to medicine and everything. For you, this kind of discrete mathematics thought process is much more useful than the pure mathematics side. Do you get that?
Okay,
Because you will be interacting with the human being and the other microorganism or something, interacting with our human body and the different human parts and everything. That may look like we cannot always look for a straightforward logical way of explaining them. Do you see that?
okay, yes, sir.
Okay, so there will be always there can be some change in the property. That tolerance has to be taken into picture. Then also randomness will come into picture. We understand that also, right?
Yes, sir.
So put together, even without randomness, something may not behave in the way it is defined. So that tolerance has to be given room. And also the randomness, what changes the randomness can produce, that has to be taken into consideration also.
Yes, sir.
So like for people working in the other side, may not be even collecting data. So if you collect the data, what is the data means? Put it like even the Facebook, like you have account in Facebook, I have account in Facebook. We may be clicking lot of things. So that indirectly the data is having some kind of character, what that person is. Do you get that?
Okay, yes, sir.
So I may be searching for something today. Okay, what is the meaning of surjection or bijection or something like that? And some other time I may be looking for what is the price of some washing machine or something like that. So the data what I produce by clicking is indirectly telling I am a person who involved with the studies in computing science or some discrete mathematics. And also if for my personal life I'm looking for washing machine kind of person. Do you get that?
Yes, sir.
So that is why the computing science need this discrete mathematics very much important also. So when we analyze and process the data, we should take into consideration the discrete side of the data. Okay.
Okay.
So
Yes.
okay, let me share the whiteboard. Okay, 1 second. Where is the whiteboard? Okay, here. Can you see the whiteboard?
Yes, sir.
Okay, so we are saying that we have a function in the name of f of x equals 1 minus 2x. So I don't say discrete mathematics or pure mathematics, but we have been trained about this for many years, and human brain is more easy to understand this and process this, because this we know that if I ask you to draw a tabular column and write between this x and f of x, you will immediately do. Do you get that?
Yes, sir.
And if I ask you to draw a graphical representation between this x and the input x and the f of x also, you could do. That is what I was saying. So we will choose here orthogonal axis. This horizontal axis you choose for the all the possible ways of the x. So now I would, okay, this is going to be our y-axis, but we are going to use the y-axis for the f of x value. Do you get that?
Yes, sir.
So all possible ways. So still we have not plotted the 1 minus 2x, but we are making a platform to plot this. Do you get that?
Okay, yes, sir.
So the intercept is going to be a 1. Then it is going to be a very steepy negative 2. So this is going to be something like this. Makes sense to you?
Okay, yes.
Okay. So we say that this is our f of x. So all the points defined by this 1 minus 2x should fall in place. So here, this is all pure mathematics. Our understanding, solving problem and everything is all fine. But now, can we add this? It's not that we should understand only this way. Can we put up everything as So I draw a equivalent. This is the discrete side. Discrete mathematics. Okay. What we are saying, again, f is a function defined as real mapped to real. Is that okay?
Yes.
You see, this is what the discrete mathematics representation itself. It won't be represent. This is the pure mathematics. Okay, pure mathematics.
Yes.
So here, when we take an example of an f, which we are very convenient and we have an idea, f of x is also 1 minus 2x. Now, working here also with the tabular column, okay, I use the table also here to make it pure mass. We'll use that also, x and f of x value. Okay, f of x value. Then if I ask you what is minus 2, you will give a number. What is minus 1? 0, 1, 2. So 0 will be a 1, right?
Yes, sir.
So 1 will be a minus 1, right?
Yes.
Be a minus 3. So on the positive side, it will be a 1 and a not a 1. Negative 1 will become a, no, when you put a 1, yeah, if you put a negative 1, 1 plus 2 will be a 3. Am I right?
Yes, sir.
2 will be a 5. Is that okay?
Yes, sir.
So these are all the different way we analyze and look into, and we can do a lot of mathematical things like we can differentiate and talk about that and everything. But when you come to the discrete mathematics, we don't do like this. The analysis or try to understand what this f of x means with this definition or mapped to or. This is actually our domain mapped to the codomain. Do you get that?
Yes, sir.
Both are real quantity. So now to look into properties, let's start with the first property we know. First property is our injection. How to understand this particular function is injective or not. What is the meaning of injection? This is 1 to 1, right?
Yes, sir.
How you prove it? How you prove that this is 1 to 1?
Okay, so
What is 1 to 1? So every
element in the domain has one element in the codomain.
and it
Mapped to
will be 1 to 1. That means you cannot have two different input
Yes.
mapped to the same output.
Yes, yes.
Also the other way, if you have one input, it should not be mapped to two different output. Do you get that?
Yes, sir.
So how to prove that? What is the best way for this mathematical function, linear function 1 minus 2x? So you might have studied the proof in the pure mathematics also, right? Like prove by something, like by induction or prove by contradiction. Have you studied that?
For this, no, uncle. You done it for
No, not for
symmetric.
this. In pure mathematics, I'm saying.
Yes, uncle.
So if I give you a problem like prove by contradiction, square root of 1 minus 2 is irrational. So like that, think from the, I mean, I'm not going there, but you understand. I'm not giving you the solution for the problem I have given, but you know what is the meaning of proof of contradiction?
Yes, uncle. So we have to assume that it is
Exactly. So that is a best way to, one of the best ways actually, to prove the injection. So start with an output. Okay, take two elements. Okay. So f of x, let's say f of x, this is the function is operating on the input x. Let's equate this to f of y.
yes, uncle.
So we are assuming that two different inputs, x and y, output is the same.
Yes, sir.
So this is actually, we are starting with many to one. Do you understand this?
Yes, uncle.
This is something like contradiction. Contradiction. We start with this for this function because this is not the, this is why this is contradiction, because many to one. Is that okay?
Yes, uncle.
Okay, so this is the starting point. Let's say if we try to do that, then we are saying 1 minus 2x must be equal to, this leads to, do you understand that?
Yes, uncle.
1 minus 2y. So this eventually will lead to x is equal to y.
X is equal to y, yes.
So that means if you take the outputs are same for two different inputs, the input itself, they are equal.
Yes, uncle.
Inputs are equal. That means it is injective. So we proved that F is injective. Makes sense to you?
Yes, uncle.
So here we have not used any table column. Here we have not used any graph or anything. But this can be understood like if you take a one particular x value, if you go to the function, this will give you a distinct output. Do you get that?
Yes, uncle.
But it is not a good idea. Always use the graphical way to understand this.
Yes, uncle.
So we take two different values. If you take two different points as f of x value and f of y, let's say this is our f of x and this is our f of y, but it will happen to be in the way we work with the discrete mathematics, this will become the same point. You cannot have two different points. That is what it is saying. Makes sense to you?
Yes, uncle.
Can you map them? Do you get that idea?
Yes, uncle. Yes, uncle.
Okay, so now we can, so allow your thought process to work along those lines. Otherwise, this will help you a lot. I mean, even this extension of not looking for a finite, definite answer or a fixed way of doing things, the study subject-wise, you need to start increasing your capability of in a more universal way of looking at something. Is that okay?
Okay, yes, uncle.
Okay, so now when we say that we have the last one we have discussing, that is for what? We are going to say that the surjection, yeah, okay, surjection is not the one we have not seen. Okay, surjection, let's try that. Surjection onto, do you get that?
Yes, uncle.
Onto, that means every output should have an input from the domain. Is that okay?
Yes, uncle.
So here we are not talking about one-to-one. Here we are talking about there may be some output elements in the codomain which the function may not have the input.
Yes, uncle.
So take a function, mathematical function, f of x is actually equal to x squared. Okay, this is the definition. For what? The codomain to the domain is R mapped to R. Is that okay?
Yes, uncle.
Okay, so in this case, we take a from the, so the surjection, how to prove for a function, it is better to start again from the output codomain side. Take a codomain, let's say take a value, -1. It's a value, right?
Yes, uncle.
So if you take the g value as g of x equal to -1, this will not have a, you don't have a R here. Do you get that?
Yes, uncle.
Okay, so that is why this particular function f of x, g of x is not surjective. Makes sense to you?
Yes, uncle.
But in the surjective, if you take a function f of x, take the linear function 1 minus 2x. Now how to prove that it is surjective or not? Same, R mapped to a real R. Okay.
Yes, uncle.
So how you go about this? Again, take from the output side because surjection is on to. Do you get that?
Yes, uncle.
So
Same thing, right?
Yeah, all the output should have a input. That is what it
Yes.
is.
Yes,
It
sir.
doesn't talk about it has to map to a only one value or something like that. You get that?
Yes, sir.
The difference between the, so let's say A is a element of our real quantity. Okay.
Yes, sir.
So if you take it, then we are saying that A is going to be equal to, so this is a, let's say this is the output. So this leads to A is equal to f of x. Is it okay?
Yes, sir.
Okay, so that means A is equal to 1 minus 2x. This leads to 1 minus 2x is actually equal to A. This is minus 2x is actually A minus 1, which leads to, because we want what is the input, x is actually minus half of 1 minus A. Is that okay?
Yes, sir.
Or we can write the other way also, half times A minus 1. So what this says, if you take a real element A, how the output is? Output is nothing but a half of a real quantity minus 1. Do you get that? This is the real
Yes.
quantity.
Yes, sir.
If you take a real quantity, take away a 1 with that, that will be a particular real value, and half of it will be a real value also. Do you get that?
Yes, sir.
So that means this finally gives that f of x is surjective. Is that okay?
Yes, sir.
Okay. So now I hope you know how to prove something is injective or surjective. Okay.
Yes, sir.
Okay. So now look into the way where we have looking into in the bijection, we were here. So we are saying that what is the cardinality? With that, we can stop today. Let's look into that. What is the meaning of that one? Okay. So we are saying that there is a bijection, that is the third property, which is actually defined as injection, intersection with surjection. Is that okay?
Yes, sir.
Okay. So now, if you have A mapped to B, if this is the domain to codomain, if it is a particular function is having the property of bijection, but it is both injection and also surjection, then the number of elements in the A must be equal to the number of elements in the B. Make sense to
Yes.
you?
Yes, sir.
Because let's say there is something like A1, A2, A3, A4, or let's keep it late. This goes to some B1, B2, B3. So the mapping should like A3 input, let's say it goes to the B1, and A1 input goes to the B3, and A2 goes to B2. Then that means it is 1 to 1. Do you get that?
Yes, sir.
1 to 1. Because of that, we say this is injective. And onto means every output has an input. Do you see that? There is no output which doesn't have an input in this function. Makes sense to you?
Yes, sir.
So this is 1 to 1 is definition is distinct input mapped to unique output. Is that okay? Unique output. But onto is going to be our every output has an input. Makes sense to you?
Yes, sir.
Then this property becomes a surjective. So put together, if he has both the injective and that means here, this is our set A. Do you see that? This is our set A. And this is our set B. We are saying the number of elements in the set A must be equal to the number of elements in the set B. That is what this is. Is that okay?
Yes, uncle.
So if it is both injective and surjective, every input will have a unique output, and every output will have input available for that. Put together only if they have equal number of elements for the domain, both the sets, input set and the output set, and they are mapped to only one to the a unique output, then that is a bijection property. Are you okay up to here?
Yes, sir.
Okay, any questions?
No, uncle.
Okay, we are going bit slow, I know that, but it will be quite helpful for your thought process, and most likely next week we try to look into the from your exam point of view, and for your thing, they will use all this understanding to go to what is transitive and other properties. Do you get that?
Yes, sir.
Okay, so we will look into that in the next week. Okay.
Yes, sir.
Okay then.
Thank you, uncle.
Okay, take care.
Yeah. Thank you.